There is an advanced field of mathematics. One of the most advanced fields, most recent fields, is chaos theory. That's one of the latest areas of study in advanced math. It's known as chaos theory. It's based on the elusiveness of randomness. We think of randomness as readily available. It turns out you can't find a random number. See, any procedure to get a random number is a procedure, non-random. You see, that's the dilemma you get into. There are two mathematical concepts that we encounter in the field of mathematics that we cannot find in the physical universe. One of those is infinity. That's where two parallel lines finally meet. We know they never do meet. So infinity is elusive. And one of the great discoveries of 20th century science is that the universe is not infinite, it's finite. Staggering implications. But the other thing that most people don't realize is another thing we cannot find in the physical universe. That's true randomness. True randomness is very elusive. Let me go into that. See, chaos theory describes the behavior of certain dynamical systems that are highly sensitive to initial conditions. They speak of the butterfly effect, how a butterfly flipping on one side of the world can create a hurricane on the other side. That's sort of the concept that's embraced here. And as a result of the sensitivity, which manifests itself as an exponential growth of perturbations in the initial conditions, the behavior of chaotic systems appears to be random. This is like smoke curling out of a smokestack and so forth. There's all these kinds of examples that are not really random, it turns out. And these systems are regarded as deterministic, meaning that their future dynamics are fully defined by their initial conditions, with no random elements involved. Their behavior, thus, is called, that's one of the kinds of chaos called deterministic chaos, or simply chaos. In the information sciences, randomness or entropy, mathematics are divided into two kinds. There's deterministic and stochastic. Most of us have learned that 2 + 2 = 4. That's deterministic. Most engineering courses, all the way into advanced engineering, are deterministic. F = ma, whatever. Stochastic equations are where the variables have some random elements. 2 + 2 = 4. Well, what do you mean? You mean 2.0, 2.1? How accurate is your 2? If your 2 is, if there's two estimates, approximately 2 and approximately 2 equals approximately 4, what's the range of variability? See, suddenly you're dealing in something other than it's deterministic. Those are called stochastic. So if you're looking for a random number, it turns out the way you get it is by getting what appears to be, what may be adequately random for your purposes. Those are properly called a pseudo-random number, because you can't find a true random number. It turns out as you try to do that, the very method you use is not random. The Rand Corporation, the granddaddy of all the think tanks I was involved with many years ago, in 1955 published a book at the time which was a milestone. The book was called 1,000,000 Random Digits with 100,000 Normal Deviates. I have one in my library. And it actually is a book. You pick that up, you think this is a joke. Here's a book, you open up this book, and it's full of random numbers. And that was a milestone in its day. Because you don't understand how hard it is to get a random number. What did they do? They used supercomputers at the time and worked to make sure that each number was not predictable. There was no periodicity. There was no periodicity, no symmetry. And so this is not as trivial as it sounds. It represented a great deal of computation to make sure that the numbers had no predictability. They were truly random. What's the defining characteristics? The total absence of design. Design and randomness are opposites in the information sciences. That's what's so absurd in our culture today, where they attribute design to randomness. That's a contradiction in terms. It's the height of absurdity. So when you see design, you recognize it instinctively. There's designing taking place. I usually talk about the beads of Waitangi. These 347 beads I spilled on the floor, I put them on a string, and it's spelled out Genesis 1, verse 1 in Morse code. And if I try to tell you that happened handedly, you laugh at me, because obviously that's impossible. Because you would, to get that turns out to be statistically virtually impossible. And so what I guess I'm saying is the point is we recognize design as deliberate. Mousetrap has 5 key parts: a platform, a spring, an arm, a trigger. And if you have only 4 of the 5 parts, you don't catch 4/5 as many mice. You catch 0. There's a thing called irreducible complexity. Without that basic complexity, you don't have a mousetrap. So there are systems that in which there are hundreds of parts, any one of which is missing, it doesn't work. That tells you it's designed, you see. And that's just common sense. And yet, so the point is, randomness is the opposite of design, so for what it's worth. We now discover that our planet is not only uniquely positioned for life, we call it the anthropic principle, it's not only designed for life, it's designed to be discovered. It's positioned in the galaxy. Its position for total eclipses opened up the whole field of spectrography. And it's positioned within as we study, we not only discover it makes life possible, it was designed to be discovered. Our position in the galaxy was anywhere else, we wouldn't be able to discover what and it goes on and on and on. It implies teleology. That means a purpose. Not only is design has a specific purpose, and that purpose is not only for life, it's to discover God. Interestingly enough, privileged planet, very key milestone. Anyway, that's exactly what the Bible points out. By the way, the reason I'm going through this extended thing here is in Proverbs 16:33. It says the lot, the chance, the dice, whatever, is in the lot is cast in the lap, but the whole disposing thereof is of the Lord. There is no such thing as randomness. That's exactly what Einstein said. One of his famous quotes is, God does not play dice. You know why he doesn't? Because if he did, he'd win. Because he knows in advance what's going to happen. So there are two imputed concepts that are elusive in our physical world. Randomness is one of them. We have stochastic versus deterministic processes. We have pseudo-random numbers because we can't get a true random number. And the whole field of chaos theory deals with this whole contradiction. And, of course, infinity. We discovered, the great discovery of 20th century science is that the universe, in the sense of largeness, is a finite universe. It may be big and expanding, but it's finite, not infinite. Staggering discovery, but definitely made. Also, what's even more amazing is on the microcosm, that if we look smaller and smaller and smaller, we get to a point where things are indivisible. We discover that our universe is made up of, whether it's length, mass, energy, time, are made up of indivisible quanta, as they call them. And that means we are in a digital simulation, a simulated environment.